Assalamualaikum, my name is Nur Najiha binti Bahrain with matric card CE180123 together with my other members Muhammad Akil Azri, Muhammad Helmi and Adil Adam for group project Computer Architecture and Organisation with coded BEJ30303. We decided to implement the Direct Memory Access DMA by using memory simulator. So let me know you first about the DMA. DMA is Direct Memory Access, transfer the block of data between the memory and peripheral devices of the system without the participation of the processor. The unit that controls the activity of accessing memory directly is called DMA controller. The DMA is high transfer rate and increases data throughput. The processor will increase the system bus for a few clock cycles so the DMA controller can accomplish the task of data transfer via the system bus. So in short, to run this project, we use Mari as simulator application of computer architecture and organization. Mari is a machine architecture that is really intuitive and easy. It's simple architecture consisting of memory to store program and data and a CPU consisting of an ALU and several registers. It has all functional components necessary to be a real working computer. In Mari, we assume a common bus scheme. Each device connected to the bus has a number, and before the device can use the bus, it must be set to that identifying number. We also have some pathway to speed up execution. We have communication path between the MAR and memory. The advantage gained using this additional pathway is that information can be put on the common bus in the same clock in which data are put on this other pathway, allowing this event to take place in parallel.
For the coding, first, loop storage. The input is kept at storage. Second, add memory. Input from the store change to the memory hold data and instruction for processing. Add CPU. Execute a computer program. And add DMA, ready to send the input to the I/O device. Storage result is store the input to the variable reset output and nice storage. That one declare for the input, declare for the storage input. Memory, that one declare for memory. CPU, that one is declare for CPU. DMA, that one declare for DMA.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akil Azri bin Azhar, and today I will present about content of assignment. For DMA that we implement is input from the storage will transfer to input and output device. Input from the storage transfer to memory with program and data. From memory to CPU with program, data and address. CPU to DMA with memory address, and DMA to input output device with peripheral address. So after we run the coding, this is RTL log that we get. Input from in the storage, PC to AC, and PC to AC is storage to the memory. PC to AC, that's decode opcode 3 is memory to CPU, and PC to AC with the decode opcode 3 is CPU to DMA. PC to memory, about DMA to output. And this our result for data part after we run the coding.
Assalamualaikum. My name is Aditya Misharil, AE1800026, and now I'm going to present about the analysis of the project. So the implementation of the direct memory access, which is DMA, is a mode of data transfer between the memory and input or output devices. This happens without the involvement of the processor. So in program, the processor keeps on scanning whether any devices is ready for data transfer. If an input or output device is ready, the processor fully dedicates itself in transfer the data between input or output and memory. So it transfer data at a high rate, but it cannot get involved in any other activity during data transfer. So this is the major drawback of program input and output. In interrupt driven input or output, whenever the device is ready for data transfer, then it raises an interrupt to processor. Processor completes executing its ongoing instruction and saves its current state. It then switches the data transfer, which causes the delay. So the processor does not keep scanning and peripheral ready for data transfer, but it is fully involved in the data transfer process. So it is also not an effective way of data transfer.
So for the conclusion, we concluded that the implementation of direct memory access (DMA) with a machine architecture that is really intuitive and easy is a simple architecture consisting of the memory to store program and data, and CPU consisting of an ALU and several registers. Next, it provides understanding on how to program in assembly goes a long way toward understanding the architecture and vice versa. Not only we can learn basic computer architecture, but also can learn exactly how the processor work and gain significant insight into the particular architecture on which are programming.
So, for question and answer, uh, I'm the number one. So, what are the unique features of your CAO project? So, for this project, we choose the direct memory access, which is DMA. It's because of this the feature of the most computer that allows certain hardware submodules to access system the memory for reading and writing. So the interaction between the subsystem and the memory is carried out independently of the CPU. And some systems that use DMA include disk driver, controllers, graphic cards, network cards, and sound cards, like and etc. So we choose the DMA as our project is because of we can see the advantage of DMA that includes the high transfer rate with fewer CPU cycles for each transfer, and there are some disadvantage also, which is include the DMA transfer requires a DMA controller to carry out the operation, hence more expensive system synchronization mechanism that must be provided in order to avoid accessing non-updated information from random access memory, which is RAM. And DMA transfer overcome the problem of occupying the CPU of the entire time it's performing a transfer. So in DMA transfer, the CPU initiates the transfer, then it does the other operation while the transfer is in progress, and it receives an interrupt from the DMA controller once the operation is finished. And this is especially useful in real life computing applications. So the DMA can lead and to catch coherent problems. And for one example, if a CPU is equipped with a cache and an internal memory, then the data DMA controller has access uh, to store in the RAM that may not be updated with the correct data stored in the cache. So that's all for me. Thank you.
I'm Muhammad Akil Azri and I will answer question number 2. What does current trend of computer architecture is relate with your project? DMA is a subsystem that can move data from one place to another autonomously without intervention from the processor. Example, if you have a 112 byte sector on a hard disk that has to be moved into memory, then you prime the DMA system by giving the memory address to move the data to the number of byte. Then you wait the disk to rotate the beginning of the sector. And the data is read from beginning of the sector, and as the data is read from this, it is picked by DMA and moved 1, 2, or 4 byte times to the memory address specific. That's all from me.
Number
Thank you.
3, explain on how your project can support the sustainable development. I think it is such a built-in clock that keep everything synchronized, and also hardwire control unit that give better performance, while microprogram unit are more adaptable to changes.
For the question and answer, question is explain the current trend of computer architecture for suitable development. Answer is modern architecture of the present and the future is intended use computer technology that allow to send computer models to production and follow them, going beyond the intermediate stage, making construction detail. This will lead to the fact the construction will be clean and very fast. Technology will make it possible to make architecture more durable but at the same time lighten.